right, so picking up with the melanin, when the UV rays strike your cells, the melanin is released because it is a protective measure that the body has developed. The melanin will actually shield the cells so that the UV rays can't target or can't get to the DNA. And so it protects that DNA from getting to that excited energy state, and it reduces the chances that that DNA is going to make mistakes when it copies itself over. So the more UV exposure you have, the more melanin that will be produced. And like I said, it will come to the surface of the skin, protect those skin cells. It protects them up to a certain level, but it can only do so much. So we, like I said, we do want to make sure that we regulate that UV exposure and we don't get too much. As that melanin comes to the surface, remember, it's going to actually weave its way in between all of those epithelial cells, and it will come to the surface. And so we'll notice our skin gets darker. But because those epithelial cells will eventually get sloughed off, after a few weeks' time, if we don't continue that exposure to the UV rays, so summer's over, we get into our winter months, we don't have as much sun exposure, we're going to slough those skin cells off. They will take that melanin with it, and that's why our skin will go back to a lighter skin tone during the winter months. So as our UV exposure changes, melanin production will vary in response to that, and you will see your skin tone also change in response to that as well. The next slide that you have on the epidermis, you have the two slides, the computer generated one and then the actual one. This is just a little bit closer up view of what the epidermis layer looks like. You can see where the color changes. So everything above that color change, that is your epidermis. The lighter colors underneath, that is going to be the dermis layer. You can see within the epidermis that you have several layers of skin, and it talks about the 5 layers that you have, from the stratum corneum to the lucidium to the granulosum to the spinosum to the basale layer. So those are the 5 layers of skin that you have throughout the body. You don't necessarily have all 5. So those are just potentially the layers of cells that you could have within the epidermis. The thicker the skin has all 5, thinner skin will not have all of those. So it just depends on where you're at in the body as to the skin layers that you have. If you take a look at the dermis, so now we're into that second layer of skin, and this is where you're going to find all of your living working structures. So when we talk about the accessory structures of the skin or the integumentary system, this is where they're going to be located, because the epidermis does not have blood vessels, does not have access to nerves directly in that layer. And so now when we get into the second layer, that's where we're going to find all of these structures. Your hair follicles, oil glands, sweat glands, all of that is going to be embedded in this particular layer. Now, the one thing that I want to point out is the dermal papillae. And this showed up in a couple of the other slides earlier, but if you look at this particular slide, it's just underneath capillary. You'll see where it's identified or labeled with the dermal papillae. The dermal papillae is kind of a peaks and valley situation that you have, and it is right between the epidermis and the dermis. It's not a straight line that separates the outer layer of skin and the second layer of skin. It is very much a rolling hills type situation. And the reason that this is so important is because we talk about fingertips. And if you ask people, why do we have fingertips? Immediately everybody goes to for identification purposes. That's a nice benefit of our fingerprints, because fingerprints are unique to the individual, but that's not why we have them. Fingerprints are actually for tactile purposes, so that when you go to pick up a piece of paper off of a tabletop, there's a little bit of grip there. Or when you go to grab anything, you just have a little bit more grip because of that surface on your fingertips. As I mentioned, it is unique to each individual because of those rolling hills. It's a little bit different from one person to the next. Now, with the formation of your fingertips, when we look at them or when we see them, they're on the surface of our skin. That's not where they originate. And if you think about what we've been talking about up to this point, that epidermis gets sloughed off. So if your fingertips were actually on the surface of your skin, your fingertips would change almost daily because that top layer of skin is getting sloughed off. So when we talk about your fingerprints, they come from the internal papillae, and that is going to be from that layer sandwiched in between the dermis and the epidermis. So those peaks and valleys push up through the epidermis layer, and that is actually what is going to create your fingerprints. It's why your fingerprints don't change, because they're actually in that next layer or that second layer. And so that's not something that gets sloughed off. So they will stay the same throughout your entire life. Looking at the next slide. So there's a second one on dermis. Go ahead and jump to the subcutaneous layer. When we get into the subcutaneous layer, this is where you're going to start to get into the fat, so the adipose tissue. When you see adipose cells within an integumentary slide, you know that you're in that third layer. So now we're into kind of the barrier that's going to help hold and maintain heat. It's also going to cushion and help protect so that if you run into things, you don't do damage. And if you look at this, it also identifies it as where your major blood vessels are present. So epidermis, no blood vessels. In the dermis, you'll start to have some small minor blood vessels, but we don't get into the majors until we get into that subcutaneous layer, because that's the first place where you're really going to have protection. So that if you run into something, you don't crush a large blood vessel and do damage to it. So the next slide talks about hair follicles. So hair follicles, as I mentioned, they are going to originate in that dermis layer, that second layer, and they will cut through. So they do have to go through the epidermis as well before they actually come out to the surface layer. So a couple of things with the hair follicles. Now, hair used to be much thicker and longer on the human body than what it is today. And the reason that we see the change in the thickness and the length of our hair, especially on our arms and our legs, is because humans, any organism, does not want to take care of something that no longer serves a purpose. So as people started wearing better clothes and having better protection from the elements, the need for long, thick hair on the arms and the legs was not necessary. Clothes took that over. And so the body actually started to thin out hair in certain places on the body where we didn't need to have it. So the hair on your arms would have been somewhere in the neighborhood of 4 to 6 inches long and much thicker. We don't need that. It's thinned out into the small, fine hair that we have today. But if you look at that picture that you have there, you have the hair follicle. The hair will actually come through that chute and then out to the surface. A couple of things that you have associated with your hair follicles. Number one is the sebaceous gland. Now, that's a fancy way of saying the oil gland. And you'll notice that the oil glands latch right into the hair follicle itself. So they will produce the oil, and then they'll actually push the oil out. And the same shaft that the hair comes through is also where the oil production is going to come out to the surface of the skin. And that's why after a few days, if you don't wash your hair, you'll start to notice that kind of shiny appearance to it. That is because that is that oil that is coming out of those oil glands. Now, the oil itself is a natural kind of lotion that the body produces. So in order to make sure that our skin, even though the epidermis is dead skin cells, we don't want it to dry out. And so we do have the ability to naturally produce this oil, which is supposed to help maintain that drying out. I know during some months of the year, it doesn't seem like it's doing what it's supposed to, but that is the goal of those sebaceous glands, is to produce oil and help protect that skin. The other thing that I want you to notice on this picture is you have a muscle that is attached to the hair follicle as well, the erector pili muscle. So if you're looking at that list on the right-hand side, you have the sebaceous gland, and then the next one under that is the erector pili muscle. So this is a small little muscle, but it's attached to that hair follicle. And what actually happens is when you get cold, in response to that, that erector pili muscle will contract. And when it contracts, it pulls on the hair follicle, and it takes that hair, which is normally laying flat on your skin, and causes it to stand up. Now, with the small little hairs that we have now, that doesn't really mean much. You guys notice it. You get a little bit of a puckering to the skin because of how that hair follicle is pulled on. You call it goosebumps. But if you took it back to when our hair used to be 4 or 6 inches long on the arm, when that happened, now you would have this dome of hair that was standing up a little bit and kind of creating a tent over the surface of the skin. So it was done as a way to hold heat to the body. So that erector pili muscle would contract, the hair would stand up and create this dome over the surface of the skin and help to hold that body heat in response to a person being cold. Now, like I said, today with the hair being so thin and so fine, it doesn't do what its intent is, but that erector pili muscle, that is why you have it there. If you go to the next slide, it talks about the nails. And I already mentioned a majority of what I wanted to talk about with the nails is that they are just nothing more than keratin, an overproduction of keratin that is produced of that glue. And that glue is going to come together, create that protective covering over the tips of the fingers as well as the toes, because those are the places where you're going to, number one, you have a high number of nerve endings. Number two, this is typically where you do a lot of your damage. So you're picking things up, you run into things, you bump things, you knock things with your fingertips and your toes. And so it was just a way to create an extra layer of protection so that you didn't do a lot of damage in those places of your body. The next one talks about the sebaceous gland. And when you talk about the sebaceous gland, like I said, this is oil production. And the sebaceous glands are going to produce oil in response to what's going on. So if you need to increase your level of oil production, your body has the ability to do that. And so as we go through the year, the amount of moisture in the air will change. So warm air is able to hold more moisture. Cold air does not hold as much moisture. So during the summer months when there's a lot of moisture in the skin, moisture in the air, then we don't lose as much of our water to the air around us. So we don't have to worry about our skin drying out as much. In the winter months, less water in the air, and so we lose a lot more water to the atmosphere around us. Our skin dries out. Now, as that changes throughout the year, our oil production will also respond to that, but it's a delayed response. And so the skin will dry out. You will get all the side effects of your skin drying out, and people will immediately go to artificial remedies. So things like chapstick or putting on lotion to, like I said, respond to the changes, that dry, cracking skin. The problem with that is your body reads it as it's producing that. So when you put a bunch of chapstick on your lips, your body thinks that it has produced that and that it's overproducing its natural oil. So it will tell your body to lower the oil production. And then you just create a vicious cycle because your natural oil production is dropping because of what you're putting on the surface. And so then you just create a system where you continually have to use the chapstick because your body's not producing enough. Your body will eventually catch up and it will increase its natural oil production. Unfortunately, most people just don't wait it out. And so, like I said, you create that vicious cycle where you're putting on chapstick or you're putting on lotion because it doesn't happen fast enough for you. The next slide that you guys have talks about sweat glands. Now, sweat glands are a little bit different. Sweat glands are going to be embedded in the skin, but they will have a direct route to the surface of the skin. So when you look at the sebaceous glands are going to be linked in to the hair follicle, and then your sweat glands are going to have their own, like I said, direct route to the surface of the skin. The way that you can tell the sweat glands apart from each other or apart from the oil glands is because the sweat gland actually coils at the bottom. So if you see a coiled structure at the bottom, that's going to be your indication that you are looking at a sweat gland, not an oil gland. The other thing is the connection to the hair follicle. So if it is not connected to a hair follicle, that is going to be your second clue that you are looking at a sweat gland, not an oil gland. Now, with the sweat glands, you do have different types of sweat glands. You have the apocrine sweat glands. You also have the eccrine sweat glands. And with the different sweat glands that you have, the sweat production is going to happen in different locations of the body. So we're going to come back to this in a little bit. So I'm not saying too much on that right now. You'll see why later. Now, with the sweat production is actually not typically associated with the smell. What happens is once the sweat comes to the surface, if it's not immediately cleaned off, then it becomes a breeding ground for bacteria. And that's ultimately what leads to an odor being attached to sweat, is the production of that bacteria. Because if you think about it, typically sweaty places, your armpits, it's a dark place, it's very warm, and it tends to hold moisture because your arms are folded down over, and it just creates a very good breeding ground for bacteria. The next slide that you have talks about the healing of wounds and burns. So when we talk about the integumentary system, as I mentioned several times, this is our first line of protection. This is what we have in order to make sure that things just can't automatically get into our body and cause infections or cause illness. So our body will go to great lengths to protect and maintain the skin. So we have what is known as the inflammatory response as it's associated with the skin. If the body determines there is a situation in which the skin is potentially going to be broken open or damaged, it will start a kind of assembly line of things to prevent the skin from being damaged. So the first thing is you'll notice that the skin is going to become red. And what the body is actually doing is if you have a place on the body where there's irritation, continuous irritation, the body is going to read that as something is trying to break open the skin. And so it's going to deliver more blood to that location because it is going to also bring with it immune cells. So that's why you'll notice a redness in that area. The body is preparing that spot in the event that it does become broken open, that it has a higher number of blood cells right there, because those blood cells are going to bring with it your white blood cells and your body's defense system. The next thing that will happen is it will start to swell up, and that would make sense because if we're delivering more blood to that location than what is supposed to normally be there, it's going to take up more room and you'll start to notice swelling. Warmness is also going to tie into this, and these you'll pretty much notice all at the same time. So the warmness, again, if you have more blood that is being delivered to that location, one of the things that blood does is it helps maintain body temperature. If you have an overabundance of blood being delivered to that area or a higher amount of blood being delivered to that area, it's going to also increase the heat in that location. And then the next step is going to be pain. So you'll have that pain production because that is your body's way of telling you that you are doing something that is potentially doing harm to your body. And so it's your body's signal to you that you need to stop doing what you're doing and then eliminate that pain or that source of irritation. Now, some people might have noticed that if you're wearing clothing, and let's say it's tight clothing, if you have a pair of socks and you've been wearing them for a long time, where the cuff of the sock is, if that's been kind of cutting into your skin, you'll notice when you take the sock off, you probably can see the imprint of the sock and it's red, which is the first one on the list. You'll notice that you might have the ridges, like I said, from the sock again. That's because that's swelling. And then it's probably going to be warm to the touch. So you've noticed all of these things. You might also notice that when you remove the sock, that as soon as you take it off, it starts to itch. That is because itching is actually the lowest form of pain that your body can register. So if it hasn't gone far enough to where you've actually done damage and broken open the skin, you might notice though that it does itch after you remove the irritation. And that's just because that is the lowest form of pain that your body will actually be able to detect. The next slide that you have talks about the healing of cuts. And this is actually a very in-depth process. When we talk about cutting your skin and doing damage to the skin, you actually have these special fibers that run through your skin, and they should be connected and in one piece. When you cut the skin, you cut those fibers, and now those fibers are exposed. Once those fibers become exposed, they release a hormone. And when that hormone is released into your body, it tells your brain that you have done damage to your body. And it will start to put into effect a series of steps to then stop the bleeding, stop the damage. So those fibers are cut, that hormone's released. The body is now going to start doing all the things it needs to do to stop that area from bleeding. It will send a particular type of protein to your body known as fibrin. Now, fibrin is a protein that you have circulating through your system all the time. Head to toe, you have this protein that is always in your system, floating around in your blood, but we keep it in an inactive form until there actually is damage. So when it's floating around in your body and it's not being used, it's called fibrinogen. That's the inactive form, fibrinogen. When there is damage, the production of that hormone is going to cause that fibrinogen to convert from inactive to active. That's fibrin. So when it's just floating around in your body and it doesn't have any purpose, there's nothing that it needs to take care of, it's fibrinogen. When that fibrinogen comes in contact with the hormone from those damaged fibers, it converts into fibrin. Fibrin is a protein that will basically form a net over the damaged area. So it starts creating these protein threads over the damaged area and creates a net or a web. As blood is coming out of that injured area, it gets packed into those threads, that fibrin. And this is where platelets are very, very important. You know that platelets are a component of blood. We get into this more in our circulatory chapter. But platelets are these fragments, cell fragments, jagged edges. And so as they're oozing out of this injury, because they have jagged sides to them, they get trapped into those fibrin threads and they start getting packed in there. And eventually over time, enough of them get packed in there that they will seal off that injury and stop the bleeding. So getting the injury sealed will take a little bit of time, especially if it is a large wound or opening. And if it's too big, the fibrin can't do what it's supposed to. But in minor cuts and scrapes, that fibrin will create that net. The platelets get trapped in there. It will eventually staunch off the bleeding and they will harden together. And that is what forms your scab. The last piece that we have talks about the different types of burns. And so we know this is another way that we can damage or injure the skin. And there are 3 classifications of burns. So you have 1st degree burns, 2nd degree burns, and 3rd degree burns. So when you look at 1st degree, those are the minor types of burns. When you get into 3rd degree, those are going to be your more severe. And that means that you have involved more tissues, you've gone into more layers, and you're getting into the accessory structures and beyond. So 1st degree is going to usually heal with no scarring or no real issues associated with it. 2nd degree will typically do the same, will take a little bit longer to heal, but for the most part, again, as long as everything is kept clean and maintained, you shouldn't have any long-term scarring or effects from a 2nd degree burn. When you get into 3rd degree burns, now you have gone into enough layers of the skin that you could potentially have scarring. You are going to have tissue damage. Usually, this is when you start to see black associated with it. So at 1st degree and 2nd degree, you'll get that waxy appearance or a red appearance with the burn. But when you get into 3rd degree, you've done enough damage that you're going to see the tissue actually be black in color. So longer recovery time, very high risk of infection, the worst burn that you can develop or be exposed to. Now, some places will actually take this out to 4th, 5th, and 6th degree burns. For our purposes, we just stay to 3. So 4th, 5th, and 6th means that you get into the muscle, that you get into the fat layer, and that by 6th, you're getting all the way down to the bone and getting into that layer or that level of the body. But for right now, we just stick to the 3, knowing that 1st degree is the minor and that the 3rd degree burn is going to be the most severe. The last piece talks about the rules of 9. And so when you have injury or burns that are sustained, one of the things that they will talk about is what percentage of the body is involved. So 20%, 50%, 80% of the body was burned. And how they actually determine that number is based on the rules of 9. So the body is then going to be broken down into different sections. You have the head, the trunk, you have the arms, as well as the legs. And each region of the body is going to be associated with a certain percentage, all based on 9. And so when a patient comes in, they would evaluate them, they would see where the burns are on their body, they would add up all of those percentages, and ultimately that is how they come to what overall percentage of the body is covered in burns. So that is the rule of 9s. You'll notice that this one says it's for adults, and that is simply because a child with a different size body is going to have a little bit different percentage breakdown than what an adult would. So you do have the videos to watch. I apologize for it being broken up into 2 different videos. So I had some help with that. But you also want to take a look at Blackboard and look at your assignment. Like I said earlier, I kind of skipped over a piece that is going to be tied into your assignment, and then bring that with you the next time that we have our face-to-face meeting, which will be on October 11th. So you will have an assignment from the last video, and then you will also have an assignment from this one. So please make sure that you have both of those ready to go the next time that we meet.